For our final sample problem here, we'll take a look at a couple different variations that you may run into. So go ahead and give sample problem number 4, part A and B, a try, and then come back and have a look at the explanation. So you can see here, again, we have a radical, and what we're really attempting to do is still isolate that radical. Now, in doing that, I'm going to subtract 5 from both sides. And now that I have the radical isolated, again, my objective is to square it to eliminate it. Now, when I square this, I also have to square the other side, and this is where we get a little bit of a special circumstance. You have to square that whole x minus 5 together. Okay, and so we'll have this root and this power cancel each other out, leaving me x plus 7 over here. However, in the left side we have x minus 5, which is a binomial that's being squared. So I have x minus 5 times x minus 5. Be sure not to be tempted to just distribute the 2 to the x and the 5. That would be incorrect. And so what we have here is a perfect square trinomial. And now we'll need to move the x plus 7 to the left side and solve this quadratic. So we'll have x squared minus 11x plus 18 equals to 0. And then I'll just use factoring for this one. So I use 9 and 2. So what I'm left with here is this. I'm going to have x minus 9 equals to 0, or x minus 2 equals to 0. And so we get two possible answers. Now, if you recall from the first page of notes in the first part of this video, we talked about something called an extraneous solution, basically a false answer. And so what we would definitely need to do whenever we have radical equations and we get 2 or more answers, we definitely need to check them for validity. So we definitely need to run a check on these two. And so what we'll do is we'll simply take the 9 and we'll put it into the original equation. And then from there, we'll just simply work on the order of operations. And you can see that we get 9 equals to 9, and so that is a good answer. So that's true, we'll keep that answer. For the second one, we'll put 2 in, same equation. Which will then give us the answer of 2 equals to 8, which we know is not true, that is false, which tells us that this x equals to 2 cannot be a valid answer. So that is how you would check for extraneous solutions such as x equals to 2. You would have to check both of them back to the original equation. Alright, part B gives us a different look in that we're now using a cubed root instead of a square root. And so this isn't going to differ too much from any of the other problems except for the power necessary to actually eliminate the root. And so let's go ahead and do like we would do originally for all of them. We would isolate that particular radical. So we have the cubed root of x plus 2. Now we'll simply want to raise this to the third power. And again, we'll want to raise the other side to the third power. The root and the power cancel out here. Now, I have a negative value being raised to an exponent. As always, you should use parentheses to do this, and you should also have a pretty good idea of what type of sign is going to come out of an even or odd power. So this is actually going to equal negative 64 x plus 2, and then x is going to equal to negative 66. Now, if you were unsure whether you did the power correctly, you could always check the negative 66 back in the original equation, just like we did for the extraneous solution. So those are two other type of examples of solving radical equations.